Okay, we're doing section 5.3b, and we won't be doing 5.3d right now, just 5.3b, which starts on page 370. So we're starting with an investigation of an isosceles right triangle. And when it is isosceles and it's a right triangle, it's going to be important to know that the angles, because it's isosceles. Great, because that just ruined my video.
Sorry.
For what?
Just to like draw.
Yeah, go somewhere else. Ugh. So using the shortcut, we know that
Cleaning paper.
so in that model, where this is the right angle, and this side's the hypotenuse. Remember we had x, and x radical 2. So this tells me in this problem, my 9 radical 2 is my hypotenuse, and it's equal to that. So I can set them equal, 9 radical 2 equal to x radical 2, and that will give me what my x is, which are each of my legs. So I just have to divide both sides by radical 2, and there I get the x equals 9. In the next problem, part B, they're giving me, this time they're giving me what x is, they're giving me the legs, and I'm going to find the hypotenuse. The hypotenuse is always going to be the legs multiplied by radical 2. So that is 2 times 2, so here x would equal 4. In part C, C is almost like A was, so C is telling me this is the hypotenuse, and I set that equal to x radical 2. Divide by radical 2, and x equals 12. So each of these sides are 12. In part D, now here's where it gets to be a little more work. So they're giving me the hypotenuse, and once again, the hypotenuse, I'm going to start calling these legs, and this would be the leg times radical 2. So the hypotenuse here is equal to a leg times radical 2. I want to know what that leg equals. My x is going to be the leg. So I'm dividing by radical 2. So we can't leave a radical in the denominator. We have to rationalize it by multiplying the top and the bottom by radical 2. That would give me 6 radical 2 on top, and on the bottom, just plain 2. And that's going to simplify. The 6 over 2 simplifies to 3 radical 2. That is going to be my x. In the next problem, I'm going to redraw this. Now here, it's drawn for you. This problem is separated into 2 different triangles. We got to treat it as 2 different. So, I'm going to start with this triangle on the left because they're giving me one of the sides of that triangle. They're giving me this is 6. So, oh, and the parallel lines are telling me that I'm going to have, that this is going to be 45 because this is, and therefore this is a 90-degree angle, and so is this. Okay, so one of the sides is 6. That's telling me that hypotenuse here is 6 radical 2. So now let me clear up the second triangle. This is 45, this is 45, so that's a right angle. The side is 6 radical 2. In order to find y, which is the hypotenuse, I've got to multiply 6 radical 2 times radical 2. And that will give me 6 times 2, which is 12. Okay, in this next investigation, Find the length of the altitude of an equilateral triangle with side length 4. Okay, they're asking me to find the altitude of this triangle, and it's an equilateral triangle, side lengths are 4. So this is a different section than before. We were dealing with 45, 45 right triangles, and this is now different. So see if you can see the difference. So in this triangle, if this is a hypotenuse and it's equilateral, this would be 2. To find the altitude, I'd have to go 2 squared plus x squared to give me 4 squared. That's 4 plus x squared equals 16. X squared equals 12. X equals radical 12, which I'm going to simplify to radical 4 times radical 3, which is 2 radical 3. So in the first example, the smaller side here is 2, and the altitude came to 2 radical 3. I want you to do the same thing right now with starting out with an equilateral triangle with each side 5. So on your own, go ahead and do that. Put this on pause, and then, oh, I'm sorry, not with 5. Change that. With each side going to be 10. So if it was an equilateral triangle, each side is 10. Go ahead and figure out what the altitude of that would be. Put it on pause and come back. So that means that the small side is 5, and 5 squared plus x squared will give me 10 squared. 25 plus x squared is 100. X squared is going to be 75. X is going to be radical 25 times radical 3, which is 5 radical 3. So in this case, the small side was 5, and the altitude is 5 radical 3. So here's what we're dealing with. When we started out with an equilateral triangle, we know that every angle is 60. When we brought down that altitude, we've divided up this top angle so that each of these are 30. So we're now dealing with a 30, 60, 90 right triangle. And in this 30, 60, 90 right triangle, we have a shorter side, I'm going to call S, a longer side, and a hypotenuse. So the angles in this triangle have the measures of 30, 60, and 90. The angle that is which angle is the hypotenuse across from? It's across from the 90-degree angle. The next question says, which angle is the short leg across from? The short leg is across from the 30-degree angle. This is going to be really important, that the short leg's across from the 30-degree angle, the long leg is across from the 60-degree angle. Now going back to those examples, when we had, this was 30 degrees, 60 degrees, when we had the bottom being 2, each side being 4, we ended up with the height being 2 radical 3. On the next one we did, when each side was 10, this is 5, this was 5 radical 3. So there's some patterns here that are going on. For each triangle, find the ratio of the hypotenuse to the short leg. If you look at the hypotenuse and the short leg, you're going to see that the hypotenuse equals 2 times the short leg, and that will always be true. So you need to find that short leg always across from the 30-degree angle. The hypotenuse will always equal 2 times the short leg. Now the ratio of the long leg to the short leg, the long leg equals the short leg times the square root of 3. And again, that's always going to be true. So let's fill it in here. In a 30, 60, 90 triangle, the hypotenuse is 2 times as long as the shorter leg. The longer leg is the square root of 3 times as long as the shorter leg. Hypotenuse, 2 times the shorter leg, longer leg, shorter leg times the square root of 3. So this triangle is what we're going to memorize for the 30, 60, 90 right triangle. And this is always going to be true. So the side opposite 30, I'm going to call X. Actually, I'll probably more often call it S. Then the hypotenuse will be 2 times S. And this one will be S times the square root of 3. We change it to S just because there are X's in the problems quite often. Okay, example 3. You make a guitar pick that resembles an equilateral triangle with side lengths of 32. What's the approximate height? So each of these are 32, and that means this is going to be 16. So if it's an equilateral triangle, that's 30 degrees, this is 60 degrees. So we go back to our model all the time. 30, 60. The side opposite 30 is S. The side opposite 60 is S times the square root of 3. So to find our hypotenuse here, we've got to go 16 times the square root of 3. And that's our answer. Okay, in part A, we have a 30, 60, 90 right triangle. We're given the side across from 60 degrees. So in my model, I'm going to rewrite it. This is 30, this is 60. The side opposite 30 is S. The side opposite 60 is S times the square root of 3. So they're giving me the side opposite 60. So I need to set 8 equal to S times the square root of 3. And this will give me the shorter side, which is what X is, which is what I'm looking for. So I've got to divide both sides by the square root of 3. I've got to rationalize the denominator and get 8 radical 3 over 3. And that is X for A. Now I have to find Y for that same one. Y is the hypotenuse. So to find the hypotenuse, I've got to go 2 times S. If this is my short side, S was 8 radical 3, I've got to go 2 times 8 radical 3 over 3. And that gives me 16 radical 3 over 3. That is my Y for part A. Part B, C, and D, I want you to go ahead and give them a try. Try to do them on your own, pause this, and then come back to it. Okay, for part B, they're giving me the short side, and I'm trying to find the side opposite 60. So therefore, I've just got to go 2 radical 3 times radical 3, which is going to give me 2 times 3, so X equals 6. That is part B. Part C, they're giving me the hypotenuse and the short side. This is a equilateral triangle. So the 30 degrees is up here, the 60 degrees is here. To find the height, I'm just going to take the short side, 6, and multiply it by radical 3. And that'll give me the height. For D, they are giving me the hypotenuse. So I've got to set 5 radical 3 equal to the short side times radical 3. And that's going to give me the short side, which is Y in this problem. So dividing by radical 3, the short side equals 5. So Y equals 5. Oh, I'm sorry, I just did that one wrong. Start it over. Start it over. Hope you caught that. They're giving me the hypotenuse, 5 radical 3, which is equal to 2 times the short side. So dividing both sides by 2, my short side, which is y, is going to be 5 radical 3 over 2. My long side means I've got to take 5 radical 3 over 2 and multiply it by radical 3. That's going to give me 5 times 3 over 2, which gives me 15 over 2. So my x is 15 over 2. Part E. So for example E, we have 2 parts. And we're going to have to start with the triangle on the right, because they give us that the hypotenuse is 8. And so if we want to find the side across from 30, that would be the small side. So the hypotenuse being 8 means I set 8 equal to 2s. And then that's going to give me, divide both sides by 2. That's going to give me that the small side is 4. For that triangle, the small side is x. So my x equals 4. Now, with the triangle on the left, that 4 is the longer side, and we want to find the shorter side. So in our model, side opposite 30 is s, and this side would be s times the square root of 3, and this is 2s. So now we know that 4 is equal to s times the square root of 3. So we're trying to find s, the smaller side, on this triangle on the left, the side across from the 30-degree angle. So I got to divide both sides by square root of 3. I have to rationalize the denominator. I get 4 times the square root of 3 over 3, and that is 4. That is my y. Sorry. Okay, let's go to F. Okay, once again, we have 2 different triangles in F. We have to start with this one on the right. And on that one, they're giving me the hypotenuse. So therefore, I'm going to set the hypotenuse equal to 2s. So 6 is equal to 2 times the smaller side. And that tells me that the smaller side of that triangle is going to be 3. So now I got to figure out what are my angles in this triangle. So looking at the whole thing, the whole triangle, I see that this is a 30-degree angle, which means that has to be 60. And then in this smaller triangle on the right, if that's 60, this is 30. And for the other triangle, that would be 60. So for what I just found, I found the shorter side, which is the side across from 30 degrees, so my x is going to be equal to 3. Now I need to go over to the other triangle and try to figure out what y would be. So what I'm going to need to know is this side, which would be the side across from 30 in that triangle. And I've got to use the one on the right. On the one on the right, this red line is my side across from the 60-degree angle, which is the long side. So therefore, the long side is going to equal to 3, the short side times the square root of 3. So this red one is 3 times the square root of 3. Now from that is now my shorter side of this triangle, and I've got to find this side, the longer side. So again, in that second triangle, for the second triangle, the long side is going to be equal to s times the square root of 3, and s is now 3 radical 3. Did I do that right? I'm looking at the wrong one here. Yeah, so I've got to go 3 radical 3 times 3. So that is 3 times 3, and the y equals 9. We're not going to do this problem right now. So look back through these and make sure that you can, try to do one without looking at the work. Make sure that you understand what you're doing.